Part 1: The Rise of the Mega Tornado. Let's start with the facts. The data shows that tornadoes in the US, especially in Tornado Alley, are getting both stronger and more clustered. Historically, twisters used to hit one at a time. Now we're seeing outbreaks of 20, 30, even 50 tornadoes from a single storm system. Take 2011 super outbreak. Over 4 days, 360 tornadoes ripped across 21 states, killing more than 320 people. It was one of the deadliest tornado events in US history. And scientists say these kinds of events are becoming more common. Tornadoes are not just happening more often, they're becoming more intense. Part 2: Climate change, the invisible fuel. Now, here's the controversial part. Scientists are still debating the exact connection between climate change and tornadoes. But one thing is clear: the ingredients that make tornadoes, heat, moisture, and instability, are increasing. Tornadoes form when warm, moist air from the Gulf of Mexico meets cold, dry air from the Rockies or Canada. That collision creates instability, the perfect storm for rotation. But as global temperatures rise, that warm, moist air is becoming hotter and heavier with water vapor. The more heat and moisture you add to the atmosphere, the more violent the energy release can be. In short, climate change isn't creating tornadoes directly, it's turbocharging the atmosphere. Part 3: Supercells, the monsters behind the twisters. Most tornadoes come from supercells, which are massive, rotating thunderstorms that can last for hours. Inside these storms, a small pocket of rotating air called a mesocyclone can tighten and spin into a tornado. But here's what's new: supercells are forming farther east and lasting longer than before. Traditionally, tornadoes were centered in the Great Plains, Oklahoma, Kansas, and Texas. Now, they're shifting towards states like Mississippi, Tennessee, and Alabama, areas with more forests, more people, and less infrastructure for tornado safety. That shift means more destruction and more deaths, not because the storms are inherently deadlier, but because they're hitting where people are less prepared. Part 4: The Shift of Tornado Alley. Scientists have begun referring to the new Tornado Alley. Over the last 40 years, the frequency of tornadoes in the Central Plains has decreased slightly, while the Southeast has seen a surge. Why? It comes down to geography and moisture. The Southeast gets more consistent warm, moist air from the Gulf, even in winter. And because of the Appalachian Mountains, storm systems slow down and stall, dropping torrential rain and spawning long-track tornadoes that stay on the ground for miles. For residents, that means less warning time, more nighttime tornadoes, and higher casualty rates. Part 5: The Role of Jet Streams. The jet stream, that high-altitude river of air that circles the planet, plays a crucial role in tornado formation. It helps control how fast storms move and how much they can spin. As the Arctic warms faster than the equator, the jet stream is becoming wavier and slower. That means storm systems linger longer over certain areas, giving tornadoes more time to form. The slower these systems move, the more destruction they leave behind. It's not just the strength of storms increasing, it's their duration. Part 6: Why tornadoes are getting wider. Another shocking trend is the size of tornadoes. Decades ago, most twisters were a few hundred feet wide. Today, some exceed 2 miles in diameter. The 2013 El Reno tornado, for example, reached a staggering 2.6 miles wide, the largest ever recorded. Wider tornadoes pack more energy, stay on the ground longer, and sweep a much larger path of destruction. These massive systems form when the parent supercell has extreme updrafts and moisture, both of which are becoming more common as the atmosphere warms. The result is storms that no longer just destroy neighborhoods, they erase entire towns. Part 7: The Rise of Clusters and Outbreaks. We're also seeing more tornado outbreaks, days when dozens of tornadoes form in rapid succession. In the past, these were rare. Now they're an annual event. Why? It's because of how storm systems organize themselves. Modern climate conditions, more heat, more humidity, and slower moving cold fronts, create sprawling systems that can spawn multiple rotating cells. Each one can form its own tornado. It's like watching nature's version of chain reactions. One storm triggers another, and the outbreak spirals into chaos. Part 8. The danger of nighttime tornadoes. One of the deadliest shifts is happening after dark. Nighttime tornadoes now account for a growing share of fatalities. People can't see the twister coming, warning sirens fail to wake everyone, and radar detection is often trickier in complex terrain. The Southeast, with its rolling hills and thick forests, is especially dangerous. Tornadoes here are often rain-wrapped, meaning you can't see the funnel, just a wall of rain. By the time it hits, it's too late. Scientists call this the visibility gap. It's a deadly combination of geography, timing, and human vulnerability. Part 9. Urban expansion and human impact. We also can't ignore the human factor. As more people move into suburban and rural areas, the risk of destruction rises. Tornadoes that might have once ripped through empty farmland now hit densely populated neighborhoods. And modern construction, especially mobile homes and lightweight structures, often can't withstand even moderate tornadoes. A single EF2 can destroy entire trailer parks. It's not just nature getting stronger, it's us putting ourselves in harm's way. Part 10. Advances in tornado detection. On the bright side, technology has improved dramatically. Doppler radar, storm chasers, and satellite data allow meteorologists to detect rotations earlier than ever. The average lead time for warnings is now about 13 minutes. A small window, but often enough to save lives. AI and machine learning models are even being trained to predict which thunderstorms are likely to produce tornadoes hours before they form. These tools won't stop tornadoes, but they can help reduce death tolls, if people take the warning seriously. Part 11. The EF scale and changing measurements. The enhanced Fujita scale measures tornadoes from EF0 to EF5 based on wind damage. But here's the catch. It's based on damage, not actual wind speed. That means some massive tornadoes might be underrated simply because they didn't hit populated areas. New research using Doppler radar and mobile sensors has revealed wind speeds exceeding 300 miles per hour in some tornadoes, far beyond the EF5 threshold. So even though EF5 is technically the maximum, nature doesn't play by our categories. Part 12. Climate models and future predictions. So what does the future look like? Climate models suggest that while the total number of tornadoes each year may not increase dramatically, the strength and clustering will. In other words, fewer mild tornadoes, more outbreaks of violent ones. We're likely entering an era of high-end events, longer-lasting, more intense storms that defy seasonal expectations. Tornado season may soon be year-round, especially in the southern US, where warm, moist air is always present.